Okay, so for this lesson, we're going to talk about the definition of zero and negative exponents. This lesson, essentially you just need to know the rule here and apply it to as you go through the lesson. Much like when you say, for example, if I say I'm going to any number times 1, the rule of that is if you're any number times 1, it's that number, right? So if I say 2 times 1, the number's 2. It's that kind of rule. It's just no matter what happens on the rule, this is the answer. So for instance, look at the first one here. A, so any number, to the power of 0 is 1. So anytime I write a number and I put it to the power of 0, it equals 1. If I say 7 to the power of 0, the answer is 1. If I say 247.5 to the power of 0, it equals 1. Always equals 1. So anytime you see that to the power of 0 equals 1. That's just a rule you have to memorize. Okay, now let's look at how we handle the negative exponents. If I have a to the negative n, it's technically the reciprocal of a to the n. And that doesn't make sense, but let me show you. This is where it's going to make more sense. If I have a number to the power of a negative number, you can write that as 1 over a to whatever that negative number was. Okay? So, for instance, if I have 2 to the negative 1, you can't have a negative in the exponent, so to simplify that, you're going to say 1 over 2 to the negative 1. Or, it becomes, 2 to the negative 1. Okay? Not negative, 2 to the 1, sorry. It's when you move it below or above this divide sign, that's what gets rid of the negative. So since it was above the divide sign, technically this is over 1, right? When I moved it below, it gets rid of the negative sign. Now can I simplify that? Yeah, it would just be 1 over 2, right? Because 2 to the power of 1 is 2. All right, so then if I have, I'm going to erase this top. If I have the last one, where I have any number to the power of n also equals 1 over 8. You can put it on the bottom by making it negative. So for instance, if I have a whole number 2, right, you can write that as 1 over 2 to the negative 1. Now, you'll never really do this. What you'll do is go from this back to here. So you'll have somebody, the problem will say, how do you simplify 1 over 8 to the power of negative 3? Okay, well, all that is just move this above and it'd be 8 to the power of 3. Okay, as soon as it crosses that division line, that's where the negative can be changed to a positive.
Is that every time?
Every time. You can go from the bottom up and you go from the top down. Okay, the reason we might have a negative in here is, remember when we're doing division? So let me go to the next page. Like if I have 8 to the power of 6 over 8 to the power of negative 2. Okay, how do I simplify that?
Subtract.
Remember, these subtract.
Yeah, so that would be 4.
So you could write 8 to the power of 6 minus a negative 2. But you see what it does there. 6 minus a negative 2 becomes 8 to the power of what?
4.
No. When you have a negative next to a negative, that's a?
Positive, yes.
So it becomes 8 to the power of 8. So that's what you got to be careful with when you see this negative down here on the bottom. Okay? So let's do a couple examples. Write the journal. All right, there's several here we're going to do. So we have 3 to the power of negative 2. And all we're doing on all of these is simplifying or solving. So if I have 3 to the power of a negative 2, looking at your journal, the key concept, which of those rules am I going to use? First, second, or third?
The second one?
The second one, right?
Yeah.
So I'm going to be able to write that as 1 over 3 to the power of a positive 2 now. Now, if they tell you to solve this, then you finish it. So I'll have 1 over, what is 3 times 3?
3 times 3 equals 9.
Yep, so this is your completely solved. If they just tell you to simplify it, you can leave it here. But for this lesson, you'll probably be solving it all the way to the end. Okay? All right, so let's look at B. I have -7 to the power of 0.
Equals 1.
Equals 1. That's just a rule you have to memorize. I just taught that to my other grade.
Equals 1.
Uh-huh. All right, C is 1/5 to the power of -2. So we just have this ugly fraction to the power of -2. How would I rewrite this? Which rule am I going to use?
The third? No, the first one.
The second one still.
The second one too?
Uh-huh. So I'm just going to write 1 over 1/5 to the power of 2. Now you can't leave a fraction in the bottom of a fraction because that's messy. Okay, so we are going to simplify this. Okay, so let's walk through this together. First, I'm going to simplify that bottom number, right? Remember the 2 applies to the 1 and to that 5. So I'll just say 1 over 1 squared is just 1. What's 5 squared?
25?
Yes. Okay, so now I've applied that exponent, got rid of the exponent, but I still have a fraction in a fraction, which you cannot do. Remember, this right here, it's technically saying 1 divided by 1 over 25, right? So I can divide fractions by flipping it and multiplying. So I can say 1 times 25 over 1, because you flip the second fraction and multiply. Okay, what do I get here if I multiply?
25.
Yep, my answer becomes 25. Okay, it's real important you don't rush through these steps because it's easy to make tiny little errors that end up with the wrong answer at the end of it. So just make sure you go carefully through each step. Okay, now there's one example, one more on this. If I have 0 to the power of -5, okay, your instinct's going to go 1, right? Because we know that 0 and all that, but that's when the exponent is 0. This is actually something you cannot solve. So if you ever see 0 to the power of anything, all you have to write is undefined. All right, so here's another set of rules that, again, you'll just have to get used to knowing what happens, and you've seen some of these before. Properties of exponents. So let me get my green. So pretending that A and B are real numbers, like, 2, 4, 17, whatever, and then M and N are your integers or your exponents. So if you have the same base, you see how they both have A here? And you're multiplying that, then all you do with the exponents is add them. Okay, we've practiced this. I think that was 7.1. If you have a base and you have a power to a power, then you multiply them, the exponents. Okay? If you have two numbers inside the parentheses that are being multiplied, the exponent applies to both of them. Okay, so sometimes you're going to get like 2x to the power of 2. So we can actually simplify the 2, but not the x. So you would apply the 2, which would make it 4, and then it would be x squared. That's all that's saying. Okay, here's the division one that I talked about. If I have the same base, so like 2 to the power of 3 over 2 to the power of 1. Okay, in order to simplify that, you're just subtracting the exponent. So you get 2 to the power of whatever 3 minus 1 is, which is 2 to the power of 2. Okay? And then the last one is when you have a fraction inside. So say I have let's make it a little harder. 3/4 to the power of 2. The 2 applies to the 3 and the 4. So it's like saying 3 to the power of 2 over 4 to the power of 2. Okay? This is all stuff you learned in the first 2 lessons. So it's kind of a quick little review. Any questions about any of these? No? Anthony, any questions?
No.
Okay. Just make sure you had it good. So let's do example 2. Put this in your journal. We have 6 to the -4 times 6 to the 4. Okay, so when we're multiplying, they have the same base. They both are 6, and we're multiplying these. What do we do with these exponents?
You multiply them?
Nope. Look at the rule.
You add them.
We add them.
You add them.
So what is negative 4 plus positive 4?
0.
Okay, and what is 6 to the power of 0?
1.
Boom. Okay, so you just got to remember the little rules. All right, B, we have 4 to the power of negative 2, and all of that to the power of 2. See, now you're just practicing all these rules with negative exponents. That's why we went over them real quick. Okay, so when you have a power to a power, what are we doing? Multiply.
Now you multiply.
Yep, so that's where you multiply. So we get 4 to the power of what is negative 2 times 2?
Negative 4.
Negative 4. Okay, how would I simplify that? It's got a negative in the exponent, so what do you do? Put it under the number 1. Yep, put 1 over 4 to the power of 4. That 4 is hard to read. There we go. Okay, and then the last thing you do is actually solve 4 to the power of 4. So you get 1 over 256. And you can do that on your calculators. 4 to the power of 4. Okay, let's look at C. This one we have 1 over 3 to the negative 4. Okay, I have a negative exponent. What do I do with that?
Exponent. Don't you do what you did in the second one?
Yeah, I'm going to, kinda. Instead of, it's on the bottom, so I need to move it across the divide sign, right?
Oh, yeah.
So I'm going to grab it and drag it to the top. So it just becomes 3 to the power of 4.
That's right.
And then 3 to the power of 4, you can do that on a calculator and you come out with 81. Technically, because remember that the word they used was reciprocal, so technically what we did is we flipped it upside down. From being 1 over 3 to the negative 4, we just flipped it over and became 3 to the 4 over 1. Now I leave off the 1 because any number over 1 is just that number. All right, last one for this example. We have 5 to the negative 1 over 5 to the 2. Okay, so we have the division going on here, so what happens with these exponents? Add, subtract, multiply, or divide, do you remember? Subtract, very good. So that's the same thing as saying 5 to the negative 1 minus 2. Okay? Well, if I have 5, what is negative 1 minus 2? It's going to go further negative, right?
Negative 3.
Very good. Okay? Now I'm left with an exponent that's negative, so what do I do with that? Put it all under 1. 5 to the power of negative, it becomes a positive 3.
And then you flip it.
No, it's already flipped. Because remember, this is over 1.
Oh, yeah.
So I brought it down where I needed to. So all I have left to do is to simplify that. So 1 over what is 5 to the power of 3?
5 to the power of 3. That's right.
It's usually a little triangle.
125.
Yep, 125. Yep, make sure you know how to use your exponent button on your calculator. Okay, so sometimes you see here on D, we used our rule, we used 3 of our rules, 2 of our rules.
2.
We did this first rule where you make the subtraction, and then once we ended up with a negative, we had to put it on the bottom. So you might have to use more than one rule on this negative stuff. All right, so now let's go look at the scary one. That looks really hard, but if you follow the rules, it works out just fine, I promise. This is when you were in 7th and 8th grade going, Miss, that stuff looks crazy. So we have 2xy to the power of negative 5. All of that to the power of 3. And we're going to simplify this. Okay? So what's the first thing I should simplify?
The 2 little numbers.
Yeah, the exponent here, right?
Yeah.
So this applies to each term in here, right? So it applies to the 2, it applies to the x, and it applies to the y.
Yeah.
So I can write that as 2 to the power of 3, x to the power of 3, and then y, and what do I do with the negative 5 and the 3? it with the y, but what am I going to do with that negative 5 and 3? Add, subtract, multiply, divide.
Subtract?
Nope. That's when it's the division. This is
Oh,
power of a power.
multiply.
Multiply. So what's negative 5 times 3?
15.
Negative 15.
Negative 15.
Good. So now we can continue our simplifying. We can solve this 2 to the power of 3, right? 2 to the power of 3 is what?
2 to the power of 3 is 9. 9 times 8.
2 times 2 is 4, times 2 is 8. Okay, x to the 3 is simplified. Now, what about this y? It's got a negative, so what am I going to do with that?
Oh, you put it in a fraction.
Put it on the bottom.
Put it on the bottom.
So now I just go make the bottom line and I say y to, then it becomes a positive 15.
Yes.
Okay, is everything simplified? Can't mess anything else up? Yep. So that's your answer.
Oh, okay.
Okay, so all you're doing is moving things around until it's simplified as much as it can be, and then you're done. I would have your journal out with you so you can review the rules as you come up on these situations. When you see that y to the negative number, you go, okay, what was I supposed to do? Look at the thing. Oh yeah, I put it on the bottom of the division sign. Okay, all right, let's do B. It's another doozy. I have 2x to the power of negative 2 and y to the 5. All of that over negative 4x squared y squared. All right, so looks crazy. Trust me, it will be fine. My x looked funny, so oh, that didn't help. Okay, so first we need to try and simplify things. According to PEMDAS, we do parentheses first. The 2x is as simplified as it can get, so exponents next. So I'm going to take this negative 2 and apply it to everything in here. Okay? So, actually, there's a faster way. Since this term is to the power of negative 2, could I just take this whole term and throw it on the bottom?
Yes.
So I can simplify this. The y just stays there, y to the 5. And I can have 2x, all of that to the power of negative 2. And then I just keep writing negative 4x squared y squared. So all I did was take that whole term, since it had a negative exponent, and move it to the bottom. Oh, it should be positive, not negative, because I moved it to the bottom. So then that becomes a positive 2. All right, so after, I got interrupted, sorry. After you have moved this expression down below, we need to simplify that. So we need to apply the 2 to everything you see in there. So I'm just going to rewrite down here y to the 5 on top. And then 2 to the power of 2 would be what?
8. 4.
2 times
2
2
times
is
2
4. X to the power of 2, I just write x to the power of 2. Then I say minus 4 x to the power of 2, y to the power of 2. Now, one thing you need to realize when you're looking at this is this still means multiply right here. Okay? If you don't put those parentheses in, it's going to look like you're subtracting right there because of that negative 4. So make sure you keep putting it in parentheses, okay? Okay, so now the last thing is to simplify the bottom. So we can combine like terms. Well, we can multiply 4 times a negative 4, can't we?
Yeah.
What's 4 times negative 4?
Negative 16.
So I'm just going to rewrite. The top stays the same still. Negative 16. So there's your coefficients. So the 4 and the negative 4 are gone. So now let's combine the x squared times x squared. That's going to give you x to the power of what?
2.
We have x squared, 2. There's an x squared and another x squared. So you're multiplying those.
4.
Yeah, you add the exponent. So x to the 4, and then you just rewrite y to the 2. All right. The last thing to simplify is to look at the y's. Okay, when I have y to the 5th divided by y to the 2nd, what do I do with those exponents? Subtract them, right? So 5 minus 2 is what?
3.
So I get y to the 3 on top, and then negative 16 x to the 4 on bottom. Now the 4 is not negative, the whole number 16 is, so you're just done. Technically, you would make the whole equation negative, so you'd say negative, and then you do y to the 3 over 16x to the 4. So this is a more proper answer. However, I still would have accepted that one.
Okay.
Okay?
Yeah.
Do I need to go back? I clicked it. You got it? Okay, good. So you're doing numbers 3 through 43, all of them.